Agenda: Introduction, Specification, Memory Handling, Processor Register, Core i5 Cache Memory, Advanced Technologies, and lastly, Conclusion. Introduction: Core i5 is using the Ivy Bridge microarchitecture. Ivy Bridge is the code name for Intel microprocessor using the Sandy Bridge microarchitecture. Ivy Bridge use a 22 nanometer process. The Ivy Bridge die shrink known in the Intel TIC-top model as the TIC is based on 3D tri-gate transistor. Intel demonstrate Ivy Bridge processor in 2011. For 45 nanometer process technology, Penryn Intel Core Micro Architecture is TIC, and Nehalem Intel Core Microarchitecture Top 2009. For 32 nanometer process technology, Westmere Intel Core Microarchitecture Nehalem TIC 2010, and Sandy Bridge Intel Core Microarchitecture Top 2011. For the latest one, 22 nanometer process technology, Ivy Bridge Intel Core Microarchitecture Sandy Bridge TIC 2012. Ivy Bridge first microprocessor on Intel latest 22 nanometer process technology.
Hi and peace upon to you. My name is Muhammad Syafiq bin Yaakob. Metric number is B0819101006, and I will present about specifications for Intel Core i5 3550S Pro. As you can see in this table show the specifications for this processor. The Intel Core i5 3550S is a desktop processor with 4 cores, launched in April 2012. It is a part of the Core i5 lineup using the Ivy Bridge architecture with socket 1155. Core i5 3550S has 6MB of L3 cache and operates at 3 GHz by default, but can boost up to 3.7 GHz depending on the workload. Intel is building the Core i5 3550S on 22 nanometer production process using 1500 million transistors. The multiplier is locked on Core i5 3550S, which limits its overclocking capabilities. The next table shows the memory specifications. With a TDP of 65W, the Core i5 3550S consumes typical power level for a modern PC. Intel processors support DDR3 memory type with a dual channel interface. Next is graphic specifications. For communication with other components in the machine, Core i5 3550S use a PCI Express Gen 3 connection. This processor features the Intel HD 2500 integrated graphic solution. The graphic base frequency is about 650 MHz and the maximum dynamic frequency is 1.15 GHz. The last table shows the advanced technologies. Hardware virtualization is available on the Core i5 3550S, which greatly improves virtual machine performance. Additionally, IO-MMU virtualization is supported so that guest virtual machines may directly use host hardware. Programs using Advanced Vector Extension (AVX) will run on this processor, boosting performance for calculation-heavy applications. This is the i5 architecture of Intel Core i5 3550S processor. As you can see, the architecture of i5 processor uses the Intel 6 or 7 series chipset family. The processor uses 2-unit DDR3 DRAM technology, which has the maximum boost of 1600 speed. It also utilized the PCI Express 3.0, which landed upon 1x16 lane and 2x8 lane for PCIe hard cards and graphic cards. The Intel processor and Intel 6/7 chipset families connected by DMI2x4 and Intel Flexible Display Interface. In Intel chipset families use digital display and analog CRT. For the SAT chipset using serial ATA, USB 2.0 or 3.0 and Intel HD audio. This chipset also have gigabit network connection. It also built in with PCI Express, 8 PCI Express 2.0 that work as a controller for Wi-Fi or Wi-Fi Max. Memory handling. PEG port or PCI Express graphic port are prefetchable base or limit registers. This allows the PEG unit to claim input-output accesses above 32-bit. Addressing of greater than 4 GB is allowed on either the DMI interface or PCI Express interface. The processor support a maximum of 32 GB of dynamic random access memory. No dynamic random access memory will be accessible above 32 GB.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amr Alif bin Nabila. I want to explain about processor registers and cache memories. The processor contains more than 430 registers. First, PCI device 0 function, 0 configuration, space registers. Second, the PCI device 1 function, 022 configuration space registers and extended configuration registers. Third, PCI device 2 configuration space registers. The device 2 I/O registers. Then PCI device 6 registers and PCI device 6 extended configuration registers. Direct Media Interface Base Address Registers DMIBAR. The MCH-BAR registers in Memory Controller Channel 0 registers, Memory Controller Channel 1, Memory Controller Integrated Memory Peripheral Hub IMPH, Memory Controller Command, Memory Controller MMIO registers, Broadcast Group registers, Integrated Graphic VTD Remapping Engine registers, PCU MCH-BAR registers, PX-PEP BAR registers, and lastly, default PEG/DMI VTD Remapping Engine registers. Core i5 cache memory have a 32 KB instruction and 32 KB data first level cache L1 for each core. It also have a 256 KB cache instruction data second level cache L2 for each core. Furthermore, it's up to 8 MB shared instruction data third level cache L3 shared among all cores. And lastly, the ring design is quick, simple and has many advantages. Shorter spots, easily scalable to include more cores if required. This is the IV BEEC microarchitecture.
Moving on to the advanced technologies that are embedded within the Intel Inside Core i5 processor. The first technology is the Intel Virtualization Technology, VTX in the short form. The Intel Virtualization Technology for directed input-output makes a single system appears as multiple independent system to software. This allows multiple independent operating systems to run simultaneously on a single system. The Intel Virtualization Technology for directed input-output adds chipset hardware implementation to support and improve the I/O virtualization performance and robustness. The next technology is the Intel Trusted Execution Technology. This technology defines the platform-level enhancement that provide the building blocks for creating trusted platforms. This provides the authenticity of the controlling environment such that those wishing to rely on the platform can make an appropriate trust decision. The second is that it determines the identity of the controlling environment by accurately measuring and verifying the controlling software. The next technology is the Intel Hyper-Threading Technology. This technology allows an execution core to function as two logical processors. While some execution resources such as caches, execution units, and buses are shared, each logical processor has its own architectural state with its own set of general purpose register and control registers. This feature also must be enabled using the BIOS and requires operating system support. This BIOS can be accessed by booting up the computer and pressing the Del or F1 and 2 according to your system manufacturer. The next technology is the Intel Turbo Boost technology. This allows the processor core to opportunistically and automatically run faster than its rated operating frequency render clock if it's operating below power, temperature, and current limits. The Intel Turbo Boost technology feature is designed to increase performance of both multi-threaded and single-threaded workloads. The next technology is the Intel vPro technology. This technology is a set of security and manageability capabilities built into the processor aimed at addressing 4 critical areas of the IT security. The first critical area is the threat management, including protection from rootkits, viruses, and malwares. The second is that the identity and website access point protection. The third is the confidential, personal, and business data protection. The last one is the remote and local monitoring, remediation, and repair of PCs and workstations. The next technology is the Intel 64 architecture. The Intel 64 architecture delivers 64-bit computing on server, workstation, desktop, mobile platforms when combined with supporting software. The Intel 64 architecture improves performance by allowing system to address more than 4 GB of both virtual and physical memory. This predecessor is the Intel 32-bit, which basically can use 4 GB of both virtual and physical memory, while the 64 can enable it to further use 4 GB more than memory. The next technology is the Intel anti-theft technology. The Intel anti-theft technology helps keep your laptop safe and secure in the event that it's ever lost or stolen. The Intel 80 requires service subscription from an Intel service provider. It basically detects device theft, locks down lost device, and restore operation easily. The next technology is the Intel Advanced Vector Extension, the latest expansion of the Intel instruction set, which is this technology. It attains the Intel Streaming SIMD extension from 128-bit to 256-bit vectors. Intel AVX addresses the continued need for vector floating point performance in mainstream scientific and engineering numerical applications, visual processing, recognition, data mining synthesis, gaming, physics, cryptography, and other application areas. Alright, the next is the Advanced Vector Extension. The AVX introduced support for 256-bit wide SIMD register. This is the architecture for the AVX architects SIMD. So basically, the 256-bit offers a wider range of register, while the lower 128 bits or YAM register can only be used as 128-bit registers. Next is the Intel Advanced Encryption Standards New Instructions. This is a set of single instruction multiple data SIMD instructions that enable fast and secure data encryption and decryption based on the Advanced Encryption Standard AES. Intel AES-NI are valuable for a wide range of cryptographic applications. For example, applications that perform bulk encryption, decryption, authentication, random number generation, and authenticated encryption. The AES is broadly accepted as the standard for both government and industry applications and is widely deployed in various protocols. The AES consists of 6 Intel SSE instructions, 4 instructions namely AES-SANC, AES-SANC-CLAST, AES-DAC, and AES-DLAST facilitate high-performance AES encryption and decryption. The AES-SIMC and AES-KEY-GE and AES-SYST support the AES-key expansion procedure. For the last bit is the execute disable bit. This technology allows memory to be marked as executable or non-executable. when combined with a supporting operating system. If code attempts to run in non-executable memory, the processor raises an error to the operating system. This feature can prevent some classes of viruses or worms that exploit buffer overrun vulnerabilities and can thus help improve the overall security of the system. This technology basically advance the security of the operating system.
Conclusion: Core i5 3550S is built over Ivy Bridge microarchitecture, processor supporting L3 cache memory. Most of Intel latest technologies are supported like anti-theft, vPro and virtualization.